My name's John. I focus a lot on our both our open source and kind of our enterprise products, but a little bit more on the open source side, and get to do a lot of our events, speaking, webinars, and just build some cool technical tutorials for everybody to use and follow along with. But yeah, so that's me. Sally Ann, I'll let you introduce yourself as well.
Yeah. Hey, everyone. I'm Sally Ann. I'm a senior product manager here at Arize. I've been with Arize for just about 2 years now, worked on a variety of things, but most recently I've been really focused on our Copilot product. So we'll hear a little bit more about that later on. But really excited for today's talk. I think agents I've just been hearing so much about them this year, huh?
Yeah, definitely. It's a hot topic for sure. And I'm really excited for our session today. Sally Ann has built one of the coolest products we have in Arize in the Copilot, and so I'm excited to go into that and to talk more about what that looks like.
Yeah, it's awesome.
All right, we can probably get going here. I see we have a good amount of people, and I'm sure we'll have some as we add in. Got a little kind of housekeeping at the start, so let's jump in, and then because we have a lot of content that we want to make sure we cover. So everybody, welcome back to our series that we have on agents. I should probably change this to our ongoing series on agents because we're now into our second session. So for anybody who missed it last week, we had a session on agent architectures, kind of going over what is an agent, what are the pieces of it, and how you can kind of get started with agents. Today, we're going to do a lot more focusing on two different frameworks that you use for agent development. So we'll look more at LlamaIndex, workflows within that framework. We'll look at LangGraph. We'll look at some other kind of options. And then we'll also talk about a Copilot agent that we built. Looking forward over the next few weeks, we've got some really cool sessions. We're going to be doing a session next week on evaluating agents, and then we'll be doing a session the following week on looping in agents, how to kind of break your agents out of loops. We'll have a special guest from Haystack joining us there, Tuana, who's our DevRel lead, which is great. And then we've actually changed up a little bit of the structure here for our last two. We're going to do kind of like agent master classes. We might be a little bit more specific about what those sessions will be as we get closer. But we've got some very cool guests for those. So for the session 5, I believe this is the right order. For session 5, we have Jerry from LlamaIndex, who will be joining our CEO, Jason. So look to talk about agents and kind of where we are today with those. And then in the last session, we will have Chi Wang from AutoGen, again, kind of with our leadership on our side. So those will be kind of more like higher level talks with some really exciting voices in the industry. So definitely make sure you don't miss those. Those will be really cool to kind of close out the series that we've had. And then I'll mention as well, too, that we are taking everything in the series plus a bunch of extra material as well that we're creating, and we're kind of packaging it up into this certification that we have. We have a couple existing certifications at Arize, but we're adding this agent-specific one. So if you've been following along with the sessions, that's something that you kind of go through and add in and kind of add to your list of accomplishments, achievements, accolades, whatever you want to call them, pretty quickly. But we'll also have that long-standing afterwards. But yeah, so really exciting slate of agent-focused material over the next few weeks. And I mentioned for last time, we did kind of a quick run through of kind of state of agents today. We talked a little bit about the React agents and sort of the failures that we've seen with some React agents moving into the sort of second generation of agents that are a little bit more like the sort of scoped down in terms of capabilities, but then leading to more value with that kind of approach. And then we talked about kind of the makeup of agents today. We talked about components, routers, skills, memory, a lot of different kind of pieces there, and touched a little bit on frameworks. We're going to go obviously a lot deeper into those today, as well as some kind of more philosophical questions around whether you actually need an agent, whether an agent is appropriate for your use case, and how you kind of think about doing that. So if you missed last session, or if you just want to recap, then we'll share the link for the last session here, but this is a lot of the stuff that we covered. And for today, what we're going to be diving into, I'm very excited. We're basically going to split this into two parts. So the first section, I'm going to go through an agent that I built in pure code, in LangGraph, and then in workflows. Same agent across 3 different approaches. And we're going to talk about, highlight some of the differences that come from each of the approaches. I'll share some kind of anecdotes as well, too, about like the dev experience of using each of those tools. So we'll go through those for the first kind of half, 35 minutes of the session, and then we'll go through a section I'm really excited about, which is our our experience building a real Copilot agent. So Sally Ann helmed up our team building this Copilot agent. If you've been in Arize, you've probably seen this at some point. And so we'll talk about kind of our process behind that, some of the decisions that went into that, and kind of our learnings from that process as well. Yeah. Awesome. And so with that, we could probably jump in. We're going to do similar to we like to do. So if you have questions along the way, feel free to drop those in the chat or the QA. Either one works. And then we'll probably take some pauses as we go through to address those. This is meant to be kind of more of a interactive session. And I'll also mention that a lot of the material I'm going to show, especially the beginning here, is like pretty specific and deep. We're going to go look through some code snippets and things like that. So if you've got questions, just dump them in there and we'll try to tackle those as we go along, as opposed to saving it off to the end. Okay. Awesome. All right. And so with that, let's get started. We'll jump first into this section of agent built in a lot of different frameworks as we go through. And so let's start out with a little bit of a background on like what's the agent that I've built in each of these frameworks to kind of like level set. Basically, what I've used here is I've created kind of like a data analysis Copilot type of agent that's a chatbot that can interact with my Phoenix instance that I've set up. So Phoenix is our open source tool that you can use to trace an application. And so I've built this agent that can kind of connect to my Phoenix instance in a few different ways and can help me kind of grasp some insights. This is like a very, very little minor version of something we did in Copilot, kind of just a little bit of a slice there. And so with the first version of this, it's just a kind of code-based agent that will be our kind of baseline in a way that we'll then compare to. So it's helpful to kind of look at the architecture diagram here to get a sense of what this agent will do. But essentially what it'll do is it will be able to have a few different skills. It'll be able to query documentation. It'll be able to, so Phoenix documentation. It'll be able to analyze some data, so pull trends out of a data set that's applied to it or kind of pull insights out of that. And then it will also be able to query a database that I have connected of traces. So again, if you've used Phoenix, you get a whole database of traces as your application's running. So I connected that to this skill here so that it can actually generate and run SQL queries over that database. And then the whole thing is powered by this OpenAI kind of router here. I'm just using base OpenAI APIs with function calling to choose one of these different skills to go to. Once that skill completes, then it'll return back to the router, and the router can decide, okay, do I call another skill or do I go back to the user with a response? And so if I jump back a little bit here, you can see you have questions like, what trends do you see in my trace latency? What this will do is actually go through, it'll first make an SQL query to pull the trace latency data. It'll then take that, that'll come back to the router. The router will have that data set, and then it will go pass that to the data analysis skill to kind of create the trends report that you see here. So in this case, it's going to use two skills to kind of go through and complete that flow for the user. And so before I pull up the code for that, I see some questions that are always coming here.
Questions on, I think some of them we're going to hit. There's some questions about when you might want to use the different frameworks like AutoGen, CrewAI, LangGraph, et cetera, what the strengths and limitations may be, and also a request to share the code at the end of all of this. So that's what we've got so far.
Awesome. Yeah, so we'll touch on the first as we go through different kind of insights and considerations for different frameworks. I'll mention that today it's going through LangGraph, LlamaIndex workflows and code-based. AutoGen and CrewAI could be another version of this that we probably will do actually coming up soon as well, because they tend to be more like coordinating groups of agents to do things as opposed to defining an individual agent. It's a little bit of semantic difference, but they kind of have a slightly different approach there. So maybe something we can touch on a little bit later as well too. And yeah, it depends you. I'll share, I should mention actually, this is a great reminder. I'm going to share all of the code that is used here today, probably in the next like day or two. I think we're just sort of PRing that into our repo, but we're going to share all of the agent code for this. And there'll be a much longer write-up too of this first section that I'm sort of just sitting and finishing up right now, that I'll go into a bunch more detail. Cool. And I'll talk about these last ones before we keep going. So what is the use case for Phoenix again? Great question. Phoenix is, the main use case there is that it will provide observability on whatever LLM application that you have. So yeah, it'll give you kind of log level trace data on different calls to your application. It'll track latency, token usage, and then you can attach other evaluations. Like you could evaluate for hallucinations. In this agent example, we might evaluate function calling and choosing the right function. How good is it doing that? but it's basically a tool that you can connect to your application to give you full visibility into everything that that application is doing. And the goal for this course, can we expect, so another question we got is, what's the goal for this course? Can we expect John to work through our own framework throughout these sessions? I don't think let me see if I'm understanding this correctly, because I don't think the goal is that we want you to build your own framework or anything like that. I think the main goal of this session is to give you more insight into some of the different frameworks that are available and what some of the benefits and drawbacks of each of those are. So I think that's the main goal for this session today. For the course overall, the goal is to give you a full picture of what are agents, how do people build them, what are some of the considerations that you have to make and architectural decisions that you have to make when building an agent, and then some more kind of industry level, where do we see agents going and kind of things there. So I think the goal for the course is to equip you to kind of build a great agent, probably more than building a framework yourself. Cool. All right, I'm going to keep us going on the main kind of track here, but please keep throwing questions in the chat as we go as well.
I'll let you know if any relevant as you go through, John.
Perfect. Thank you, Glenn. Okay, so we have our code-based agent. Let's take a look at what some of the code that powers this, each of these different pieces is. So we can start with the router. I mentioned we're using an OpenAI function calling approach for the router. So pretty straightforward in the router itself. So first thing we're doing here is we're preparing this object of messages. The way that OpenAI likes to work is that you kind of keep a running list of messages of all your kind of user message, and then your tool call response, and then your tool call kind of completion message. So you kind of build this list of messages as you go. So we are just adding in a system prompt if we haven't already done that, and keeping that list of messages up to date. And then we're going to make a call here to just the completions API to generate the next step in our agent. So this is like the call to our actual router here. One thing to note is that I'm passing in this tools object with this, you see skill map and this big long function name. For the code-based agent, I introduced my own sort of abstraction here of a skill map. This is my own kind of creation, but the idea here was I wanted to have sort of some separation between the router and all the skills, because in a real world use case, you might add skills later on in the future, you might add capabilities like that. And so I wanted to create a system where I could add skills in the future without having to change my router. So I basically added this, it's essentially like a dictionary. It is actually another kind of class and abstraction I added, but basically like a dictionary that holds the functions that the agent can call and the router can call.
I think this is something that's really important just to kind of call out as users. I think that flexibility that you're hinting at, and I'll get into this when we start talking about the Copilot, but I think that's really key as you start thinking about maybe building these agent architectures. Flexibility is definitely something you're going to want to keep in mind, and making sure that you can kind of evolve your system over time. So I just want to make that call out because that's a really great point, John.
Awesome. Yeah, the flexibility is definitely key. But yeah, so we'll make our call to a router. This will return back with either a tool call choice that OpenAI has made, or just a response to a user. And so you see we're basically splitting that out, and we're saying if there's any tool call responses in what OpenAI comes back with, then let's go handle those and then make another call back to our router. Otherwise, we'll just return back to the user. So that's the kind of flow we go through. And then if we look at this handle tool calls method here, this is where we'll handle each of those. I've made a decision here where I loop through all of the tool calls that the model has decided to come back with. So the model might decide to say, hey, you should call multiple different tools. And so I've decided to loop through all of them, basically just pull out the parameters from each of those calls that have been generated by my router call. And then we'll go and, again, use that same skill map object to call the relevant function for that function name that was decided on. And then I'm appending the message there. In practice, you may not want to actually execute. You might want to force your model to make only one choice from a tool calling perspective. Sometimes you allow it to make multiple. It's sort of up to you. I think it keeps it a little simpler if you actually just force it to make one and then handle it that way. In my use case here, none of the questions got complicated enough where it was calling two at a time. It would call more like one and then come back to the router and call another one. So I decided to loop through each of them. In practice, you could limit this to just one tool call per sort of lap of your agent as well. All right. And then the last piece of this is an example of what one of those skills looks like. So this case, it's the generate and run SQL skill here that I have. So that bottom one, if you remember our architecture diagram. And so what this has here is just a sort of description of the function. And so this is what's actually getting passed to OpenAI. So that we're passing in a whole sort of description of what the function does, what parameters it can take, everything like that. And then this is what OpenAI will use to say, okay, if I need to do like some SQL generation, let me call this function that I've been given. So it'll use this whole object here. And then you can imagine if you keep going down here, there's actually the code to run that particular skill and do the SQL querying and all that. And again, we'll make all the code available so you guys can deep dive into that if you want to. And that's kind of our whole code-based agent. So it's you can imagine we've got all of these for each of our skills. We've got the descriptions and the actual sort of code for that particular skill. But the router is pretty straightforward in terms of what we want to set up there and how it can choose to call different functions and then recurse back to itself if it needs to. And with that, let's go and look at what this looks like for a LangGraph case now. So LangGraph is, again, going to look somewhat similar in terms of an architecture diagram. Biggest differences here are that LangGraph, for anyone who hasn't used it before, uses this concept of like nodes and edges. And so we're going to have a node for what was our router, and we're going to have a node for kind of generally handling a tool call. And then that tool call handler will will go and call any tools that it needs to, get a response back, and then pass back to the router here. So we're kind of like lapping between these two in the case of LangGraph, in the router here, and then the tool call handler that is functioning as a separate node. And so if we look at some of the differences here, like you can see the architecture diagram is pretty similar, but the code is going to look very different for what we want to set. So within LangGraph, one of the things we have to do here is set up the actual graph. So this is sort of defining what the graph is going to look like and what all the different edges and things are in our graph. And so you'll notice a couple things here. One is that I am passing in tools as this specific object, basically like passing a function into like a list of functions into tools, and then I'm binding it to a model here. That sort of takes the place of what you saw us doing with the skill map earlier. The way that LangGraph is set to work here is it has an actual concept of like a tool node that is built to work with tools. And so if you've used LangChain, you might have run across like the @tool designation or decorator. And so LangGraph handles tools in its own sort of way here. So I had to kind of adapt the whole skill map approach, kind of had to get rid of that almost and go with LangGraph's abstraction for tools. And so that's the first two lines that you see here is basically setting up a model and connecting the tools to it so that it knows it can use those particular tools. And then I will go and define the graph here. And so we're creating the graph. We're using, again, this like basic tool nodes object that LangGraph provides. This is going to abstract away a lot of the work that we had done in the previous step to handle tool calls. So actually that whole handle tool calls method, if I jump back a little bit here, this whole method that we defined here is basically going to be handled for us by that tool node object in LangGraph. So if you got a function calling agent, this is going to sort of abstract away a lot of how that handles all its tools with this object here. And so you can see our graph is going to get two nodes. It's going to get an agent node, which is our router here, this one in red. And then it's going to get a tools node, which is that tool node object, just kind of this handler that we have in the middle. And then we're going to define some edges between those. We're going to go from like user input to our agent. And then we're going to find this conditional edge, which is another big difference that comes with LangGraph, where we're going to define basically this agent to should continue. And I'll show you what should continue looks like in a second. But that is what's going to decide whether or not we actually call like a tool, we go to the tool call node, or if we come back and just go back to the user. And so I'll show that in 1 second, but that's one of the biggest differences. It's like the conditional logic of which direction do you go in the graph. It's handled in conditional edges as opposed to just in like an if statement in your code. And then we'll add a final edge to go back from the tools to the agent after the tool's complete. So I mentioned what the should continue side. So you see this should continue method here. This is actually a conditional edge. So this is where if we get a response back from our router, our LLM, it's going to first go to this method here as a conditional edge and say, okay, is there a tool call in the message? If there is, then let's go to tools. If there's not, we're just going to end and return back to the user. So this like sort of 1 through 6 here, this conditional edge, takes the place of takes the place of this sort of 17 through 21 at the end here. So instead of us routing that, we're now putting all this code right here into a conditional edge. So a little bit of just like
question.
Yeah.
Oh, sorry. Yeah,
Okay.
we have some questions that would be worth kind of answering. There's one question about how OpenAI, how does OpenAI know about the data dictionary of the Dataverse, and was that in memory? Maybe start with that one there.
Yeah, so I think that's referring to like the function itself and how it knows what the function looks like. Is that, I think that's what that one's hinting at. So in the code-based example, that comes from this big JSON object here that we're passing into it. And you can see that's where we pass it into it in this get combined function description for OpenAI that just returns a big list of those JSON objects. So that's how it knows in the code-based example. And then how it knows in the LangGraph example is interesting, actually. We're about to get to that as well, too. But basically, it ends up using, we're jumping a little bit ahead here, but it ends up using a doc string that's included in the function. So we'll actually use what you see here from 3 to 10 to build that kind of description of what the function does. I'll go more to that in a second as well, too. And then some other questions that we had. I'll get into my own personal preference as we keep going. I see there's a question about my preference for LangGraph versus other frameworks. And this is in Python. There's a question, is this Python or JS? This is in Python. And I see people answering that. Messages state instead of state graph, any particular. So there's a question about using messages state as opposed to state graph. To be honest, that was not something that I was sort of deciding from an architectural perspective. So I think you could potentially use statecraft. I haven't really looked into statecraft versus messages state too much there. So potentially I don't have a great answer for you on that one. And is the code agent a React agent or a second gen agent? I would refer to the code agent as all of these as kind of second gen agents, because we're pretty specifically defining, hey, these are the functions that you can call and the skills that you can call. These are the paths we follow, and then returning back to the router once we get those. A React agent would typically more likely handle it as like, okay, let me think of the next step that I need to do, go do that step, and then come back to the agent and kind of continue that loop versus using really specifically defined skills and pathways for that. It's a little bit wishy-washy because technically speaking, I haven't gated the LLM router itself from like responding to any kinds of crazy questions that come up. So it could function more as a React agent in that approach, but it would be a little bit different there. It's meant to be more of a second gen kind of agent. And then I'll tackle these last two and then keep going here. So there's a question on, does LangGraph support multi-agent group chats, or would you just have to potentially call another agent as a function? LangGraph does support multi-agent workflows. They have a great example on their site that goes through that, of multiple agents working together. They kind of have like a supervisor and then multiple agents that work together there. They still operate on a kind of graphic structure or graphical graph structure, like a Prego-based graph structure. So the pathways by which they'll talk to each other have to be defined versus a lot more open-ended. So if you have something like Crew AI, you can be a little bit more open-ended with how your different agents work together, but otherwise with LangGraph, it's more defined. All right. Okay, there's a question here about how you get your LLM to kind of behave better with function calling, because it can mess up a lot of those function formatting and things like that. I might hold on that for now, because I think we're going to touch on some of that stuff a little bit later on, and I want to make sure I leave Sally-Ann enough time. So I'm going to keep going for that one right now, but I think that's a great question, and we will definitely come back to that. All right, I'm going to keep moving through here. So we have our should continue conditional edge. And then I showed this a little bit before, but I had to kind of remake my functions to fit within LangGraph's tool structure here. This was honestly one of the biggest differences that I had to do, partly because I had built my functions and my sort of skills as their own class with this whole abstraction I made around the skill map. And there were some pieces of that don't really work with tools within LangGraph. Specifically, it gets kind of confused if you have member functions, so functions that take self as a parameter. So if you have like 3 parameters, one of them self, and then prompt from user and one more, then those it kind of gets confused on those because the model will know not to generate a function call with the self parameter, but then LangGraph will flag that as a validation error, or more specifically, Pydantic will flag that as a validation error. There's a bunch more about that in the write-up that I have, but this was one of the biggest differences was I had to sort of redefine my tools to be just like discrete methods versus my own whatever crazy abstraction I wanted to have for the different skills and tools. So quickly going through this, I think some of my own, this is sort of my own anecdotal experience, I would say. Some of the good pieces about using LangGraph were that it's really nice to be able to define the full graph with just something that looks like this. Like this, if you're used to looking at this, this is pretty clear, which is very nice. And so having that kind of top level map of what your whole agent looks like is fairly clean and easy to use. And then some of the built-in features like a tool node are very helpful. So those are useful for me to be able to kind of go through and set up something quickly. It got a little annoying when I had to kind of extend it to fit my skills. And so that was kind of going into the stuff that I found a little bit more difficult, is that you're sort of having to map some things to the framework that you're using. And so I had to do a lot of work to get like the types correct in different ways. Debugging gets a little bit more difficult because you're kind of debugging into somebody else's code a lot of times as you go down into the weeds there. And then the biggest thing is that there just becomes this sort of extra layer of translation between what you're doing and then what the LLM is doing, or what you're trying to get the LLM to do and what it's actually doing. That's one of the biggest problems or hardest things about building an agent. It's just like convincing the LLM to do what you want at different steps. And so I think adding another layer of kind of translation there, I found to be a little bit difficult because it's like you got to get it into the format that LangGraph wants, and then LangGraph is going to go take it to the LLM, give you your response back, and then that might be different than what you wanted. And now you got an extra thing to figure out, like, did it change it in some way as it made that journey? So that's definitely one of the big areas that I think is hard to do. And then conditional edges, I think, really come down to your own preferences. If your brain works in that way, and you like separating out conditional logic into these edges, like these specific edges, then that's a good thing for you. I think it depends on how you approach that one as well too. I'm going to keep going through. I know I have a couple questions. Let's see. Are there any that would be good to call out here? Or should we come back to it in a second? Let's just
we're good to come back.
Okay, great. I want to make sure we can have enough time. So now let's look at the third variation of this and the final one, which is the LlamaIndex workflows. So again, similar kind of architecture. You have the same thing as you have in LangGraph, where you're mostly routing between like the router and then a tool call handler, kind of node of some kind. And then that's calling out to your skills. I added one extra step here that was just like a workflow setup step. I'll save that one for the write-up because there's more detail there, but that's just my own sort of architectural decision about how to create that. That's not nothing necessarily specific to workflows. In terms of how the code to actually set up the workflow, this is what it looks like to kind of create and initialize the workflow. So what you're seeing is we're extending a workflow class from LlamaIndex, and then we're adding an LLM to it. We're setting up some memory, so that same kind of state thing that we would use in previous other approaches. And then for the tools, similar to LangGraph, I had to do a little bit of work to make my tool setup work well with workflows. But basically, I had to kind of create this function tool object that LlamaIndex uses for each of my different functions, and then pass that into a list. So it was actually not too tricky to do in this case. This one was a little easier. I didn't have to redefine my skills themselves. I just had to sort of like to create the list in a different way, versus in the LangGraph case, I had to kind of fully redefine the skills. That was nice, but it was something I had to do from there. And then this first step here is just kind of preparing your agent, getting the first message ready to pass to it, and kind of go through that setup there. And so then looking at the actual router code for workflows, it looks more similar to our code-based agent than it does to LangGraph, is the kind of one of the big takeaways here. So you see, again, we're doing the same thing where we have a message that we're sending through and kind of a list of messages that we keep track of. And then we're making a call to LlamaIndex's asynchronous chat with tools call here. And you can see we're using that self tools from before. So we're setting that up. And then we're taking the response, adding it to memory. And then we are doing our little if statement of, did we get any tool calls back? If so, we're going to trigger this tool call event. So that's a new piece there. If not, then we're going to trigger the stop event. Again, a new piece with the event side of things. So I think the biggest differences between this and our code-based agent is that we're using this event approach. So if you remember, or if you looked into workflows before, it is built as an event-driven architecture. So the idea is you have steps, or think of them as nodes, essentially. Steps are nodes within your execution. And then those move between each other by triggering different events. So in this case, we've defined a tool call event and we've defined a router input event. And so we use those to move between different stages of our agent. So you'll see when I trigger this tool call event, you can see this tool call handler method that we've defined. It receives that tool call event. And so what will happen is that as long as I return a tool call event, workflows will handle calling this method and passing it to this method for me. So that's kind of the biggest difference, is that more event-based kind of movement around your agent. I'll quickly highlight too that just another thing is that workflows is really built to work asynchronously. And so it's a little difficult to get it to work synchronously. I tried to get it to work synchronously for my own testing, and that was something that got a little bit difficult because some of the underlying functions in workflows here are asynchronous. And so you have to like redefine some of those as you're extending the workflow class, which is a little bit annoying if you want to get it working synchronously. Generally, you probably want it to work asynchronously in production though. So that's maybe not the biggest critique there. Awesome. And so then last piece here is this tool call handler. This looks, again, very similar to our code-based agent from the first iteration. And so we're looping through our tool calls. We are popping out the different parameters from those. Syntax is different here because we're using a lot of LlamaIndex underlying kind of types and things and objects, but the logic is sort of the same. And then we're going to trigger our function call, add a message to our list of messages. And then at the end, we're triggering a router input event, which basically is what goes back to the router. So this is what sends us back to the router to repeat afterwards by triggering this event here. Awesome. And I mentioned I didn't have to do anything to change my skills when I was using or change my functions themselves when I was using workflows, which was definitely a plus for me. And the last piece I have here, and I'll pass it over. I know I'm barreling through some of the content here, but I want to make sure it's time for the Copilot side. Using LlamaIndex workflows, I think there was a couple things that made it really nice. One is that the logic is fully handled in steps. I think this is, again, it's going to be a personal preference here, but I'm sharing sort of my own preference on it to help you guys give have you kind of build your own opinions. For me, I thought it was much easier to say, okay, I've got a method, let me just make that method a step. Versus within LangGraph, I had to kind of split methods up into both nodes and edges. Granted, this is probably not as big of a concern if you're building from scratch versus for me, I had built it in one, I had built a code-based agent, I was trying to kind of convert from there. The other piece is that messages state was a little bit easier to track within LlamaIndex workflows. Part of that was because I had to basically, like, there was no object that was automatically accessing messages for me. So I was always explicitly saying, okay, load up the messages list and let's add to it or let's pull from it. Within LangGraph, you have that tool node object that we used, which will automatically pull from messages for you. So it handles more for you, but it does mean it's a little harder to debug because there's stuff happening that you haven't like explicitly said to do in different steps. Again, the kind of like less good side comes down to the same considerations as before. So debugging is still kind of more difficult because you're using abstractions built into another framework. And so that gets a little bit more tricky. You're kind of having to weed down different steps. It was a little hard to force the synchronous execution, as I mentioned. And the last piece is it's similar to conditional edges in LangGraph. Now we're using events. I think depending on what you're building, events may just come down to taste, essentially, whether you like the event-driven architecture or not. I think as you get more complicated agents and kind of flows, the event-driven architecture is probably going to be easier to code, but maybe harder to understand as you're trying to map it out. But just sort of comes down to taste there. So hopefully that gives you kind of an overview of some of these different frameworks. I know I went very fast through that. Again, we'll have a full write-up that goes into a lot more detail on this as well. But I want to make sure we have time for the Copilot side of things.
Yeah. I think before we get into it, there are a few questions I think are relevant for the some of the LangGraph. Might be worth kind of covering those. So there was one question, there's two in the Q&A and then one just in the chat. And so the first one I see here is you mentioned the less control over LLM call when you started going into, I think, the LlamaIndex workflows. Can you just elaborate a little bit more, John, on what you mean?
Yeah, let me jump back to that really quick because I think it's less control of the LLM call. I think this is referring to the sense that you to be honest, well, actually, to be honest, it's just, I think this is maybe we should be taking that out because you can still control the functions that are passed in. This is where it came from. It's because when you pass in the function definitions, it goes through multiple different kind of like objects here. So to like pass in the function definitions, I had to create function tools, which had a name, like the actual callable function, and then also a metadata object that had to be a tool metadata object that I then had the name of the function and the description. And so I guess the less control there is I know that that's going to end up as a JSON object for OpenAI, but that's what OpenAI takes. But I don't know what's going on as it moves through those different setups of tool metadata and function tool to like create that list. And I did run into a lot of debugging that I had to do of like changing parameter names and things like that to actually get it to properly call different functions. And I don't know if that came from those extra objects, but it might have, and it was just a little harder to debug. So it's probably not less control over the LLM call. It's probably the same theme that's come out a couple of times of more abstractions that kind of sit between you and the code.
That makes a lot of sense. Another question that seems to be clarifying is your comment about the synchronization and like is asking is it just difficult because the default is async there? Is that what
Yeah.
where the challenge really is? Yeah.
It's difficult because the default is async and workflows is still fairly new, but so there might be something in it that I didn't see. But there wasn't like an easy way, like to switch it to synchronous wasn't just, oh, change your method to synchronous or something like that, or like change like the LLM call to the synchronous version instead of the asynchronous version. I had actually go into like the workflows object, find some of the classes that are associated or the methods that are associated with that class, redefine them as synchronous. And so there wasn't like a flag to switch it over to synchronous. But yeah, it's basically just the default is async. And I didn't find an easy way to flip that over. That might exist in workflows though. So I think that that's something that I don't want to die on.
Sure thing. And then one last one before I dive into the Copilot stuff. We have a user asking if the LlamaIndex workflow seems to be closer to pure Python. Do you feel like that's correct?
I do. So again, my own personal experience, I think I found it to be a little bit like lighter in terms of what it enforces on you. So it's a little closer to pure Python. Double-edged sword though. So if you're building your first agent, I think LangGraph is really helpful for building that or building existing agents and like kind of your own version of them. There's a ton of material for LangGraph too. And it sort of forces you to be very structured in your approach, which is nice. Workflows are a little bit more open-ended. You kind of have to know more about the structure of an agent and like you have to sort of have your own opinion on what that looks like, but it's a little more free-form in terms of how you move between different steps and things.
Awesome. Cool. Well, let's dive into Copilot. So before I start going through some of my slides material, going through the architecture of Copilot, I want to call out a few things. And the first thing I really want to call out is when we first began, working on Copilot, kind of scoping out the work here. A lot of these frameworks that John just walked you through really weren't available or really weren't, well thought out. They're very early on. So some of the stuff that we've decided, like maybe if we were starting Copilot today, maybe things would be different. But we're pretty happy with where we landed. So that's one thing I wanted to call out here. We do have a lot of material around Copilot, so I'm going to cover a few main ideas here that I think are worthwhile based off the content kind of John shared. But feel free to let us know if there's anything else you'd like to kind of hear about Copilot. But with that, we can dive into it. So I wanted to give you just kind of an overview of our architecture. So John showed a lot of different architectures there. And I think the main difference between ours and some of the ones that you saw earlier on is we actually have chosen to use this more like, I guess, graphical approach where our router picks the skills, but skills can actually respond directly to the user. I'll go into more detail about that in just a second. But here we have a user who's going to ask a question to Copilot, like give me an insight about my model or application. That question is going to go through a router. John talked about routers quite a bit in this session, so I won't go too deep into that, but basically the router is then going to choose a skill or respond back to the user if it's unnecessary to call a skill. In this example here, it would call our like perf slices skill that we have, which is going to grab some data from the platform, perform some analysis, and then go ahead and respond back to the user. The user can pick other skills or have this kind of chat and it will go back and forth. with the router for to do the analysis. But at a high level, this is the architecture that we've gone through. And I do have an objective here, and I wanted to kind of highlight this too, is when it came to designing Copilot, we really designed it to be highly adaptable and iterative. We really built it with this flexibility to test, learn, and evolve. So we were really kind of like throwing ideas into the mix, seeing what sticks, and then shaping skills based on, customer feedback. So, I made the comment early on when John was talking about, having that flexibility and being able to add tools. That's something we've learned that is definitely important, but just overall being able to iterate on, the architecture, on the skills that we have is just really important. So I think that anybody here who's going to be building an agent, I definitely think you should keep that concept of adaptability and iteration in mind, because you're going to need it sooner rather than later. Cool. So I talked a little bit about router and this idea of like a hub and spoke versus graph approach. So the first thing that we initially thought of was the hub and spoke concept. If John, you want to click on the slide for me once? So this was our initial idea, and this is kind of similar to some of the architectures and the frameworks that you saw earlier, where the router is that central point of communication. So the tools are never responding back to the users. You want to click once more for me? I have a nice little visual here. You've probably seen some version of this somewhere, but we have the router, and we just have skills, and the router can pick skills, and the data is passed between the skill and the router, but ultimately the router is going to respond back to the user. So this is our initial idea, but as we started developing, we actually decided that a graph approach might be, more suitable for our needs. So in this case, the router selects the function and tools, and it can respond directly to the user. We chose this because we felt it was more streamlined, and just that direct responses really improved the user experience. So this kind of came down to more of the product side of things and what we wanted our users to experience when we used Copilot. And so that graph approach is that same visual I kind of showed you on the slide before. So it's just going to have that user go into the router, and then the router can either respond or the tools can respond. And we've had a lot of kind of success with this router design. Our router can choose multiple functions. We do have that flexibility. We also have multiple routers for different parts of Copilot as well. And that actually gives us the flexibility to do things like, give the router full range to call multiple skills, or sometimes it's appropriate for the router to only call, certain skills and only one of them. So we have also multiple routers, but they're all going to be designed on this like graph approach here. Next slide. State management and context handling. So this is something that is extremely important for our use case. So our use case here is to help users basically debug and get insights from their AI applications or ML models. And so Copilot being able to understand where it's at in a debugging session or having the context is really, really important. And so this actually tied back to our choice in which API to use. So OpenAI, or something I should have mentioned before, is we're using Azure OpenAI as our engine here. We have some stuff in our documentation if you're interested in learning why we made that choice. But with OpenAI, you have the assistance API. And at first we thought that was going to be the obvious choice, right? Because it has kind of tool calling built into it. And we thought with that, it would simplify the state management. But with that, OpenAI is managing the context and the state all with no control on our side. So it's requiring this kind of full conversation history to be passed. And that just really wasn't working as well as we needed it to. So we decided to kind of switch this explicit state control, which essentially just means that we decided to use the completions API. And so that just gave us full control. And that's something you'll kind of hear me talk about a lot as we continue to go through this, is that full control in our production setting ended up being really important to us, because we just found with a lot of some of these out of the box options, it wasn't really suitable for our needs. So we allow we do the full state control, which allows us to kind of fit all the context we need into the content window, and then just kind of optimize around that. We only include relevant context, and so we reduce any like unnecessary context that's not needed. So we kind of basically use this kind of summarizing, and I talk about that in these last points here, is we actually use a summarize state into our function. So we kind of summarize what the conversation has been, where we're at with the debugging, some insights that Copilot has already given. And we pass that in as our context instead of relying on, OpenAI state management. And this again is because, we often need to reset context Sometimes they might be in one session, but a user wants to talk about something completely different. If we didn't have this full control over state, it would be difficult to do that. And then, yeah, and I see we have a question here about
Yeah, I got a couple.
yeah, okay, let's see. How long did it take to build this in a code shareable for collaboration person? So the Copilot code is not shareable. This is our own kind of internal code. We don't share that, but we are trying to share as many insights as we can about our process, a lot about the architecture. We'll have an in-depth blog coming out about the architecture. We posted an intro blog and we posted a lessons learned. So we're trying really hard to share everything we can except for that code. But I'll give you a hint. Some of what John shared in his code-based example is not so far off from what we are doing. There's a little bit extra stuff in there, but that's on the code. And then how do we handle customers not wanting to share their analytics sent to OpenAI? Yeah, that's a really great question. So that's one of the reasons we chose Azure. There's a lot of data protections and security built in with Azure. It's kind of covered by all of, the Microsoft and Azure security. In our documentation, I actually outline what those kind of are. So if you are curious, you can go take a look there. And then, we basically have options for customers. They don't have to opt into Copilot if they don't want to. So that's one way we handle it. The other option is we do often allow for kind of custom Azure endpoints if they want to own it altogether. So those are some ways we handle it. But because of the protections and the way that we handle kind of the data, we found that, those customers are okay with it. Curious what the latency requirement for this and what type of guardrails are in place for Copilot. Yeah, really great question. I don't have that much data on like the latency. We just know that when we choose like the engine, like for example, kind of choosing which model to use, that's something that we keep in mind is the latency. We don't want a user sitting there waiting for minutes for a response. We want it to be kind of quick, and we're going to get into streaming in a little bit. And I think that kind of helps with like the user experience around latency. Not sure if that's what you're talking about though there. And as far as guardrails go, we have a few guardrails on things like, toxicity and, making sure that there's no like jailbreaking attempts. But we actually have found that we haven't needed at this point that many guardrails. We've actually found a lot of the built-in protections that you get with these models these days are quite sufficient. So there's some prompting that we do, some actual guardrails. We of course are using evals to keep track of all of these things, and then just kind of relying on the current state of the LLM engines, which if you even see in the latest like O1 report there, like the jailbreaking, it's like nearly impossible to do that with the latest models.
We also have some element to it. I know we talked a little bit about like we have authentication tied to like we sort of have an authentication token associated with the Copilot and some other kind of more like software engineering approaches to keeping things secure too. So I know that that's something we built in.
Yeah, that's a really great point. So yeah, we have the way that we design Copilot is to also like as John's mentioning, it's kind of like silo things. So like one customer can't access another customer's data. It's kind of based on the model or application. So yeah, we can definitely dive into that. We have like our whole security team helping us out on that. And like you said, it's like more of a secure or software engineering kind of perspective when it comes to that. I won't go too much into the lessons learned just yet. If we have time, maybe I'll pull up the blog. This right here, we're talking about the state management. I think this is one big lesson that we learned is just like the complexity of state management. It's not something, I think it's getting better, but when we first started thinking about this, there wasn't really like a playbook we could turn to. We had to really experiment and see what worked. I think there's a lot of space for these kind of abstractions to be made around state handling. So I think that was one call out I learned and just kind of the difference between choosing the API, and I'll try to call out some of the other challenges and lessons we learned as we go through the rest. And we'll make sure, I think we have the blog linked as well if you want to learn a little bit more about the lessons there. Cool. Skills. This is kind of, I just wanted to give like a little bit of insight into how our skills work. So we do have like a group of skills that help the router answer users' questions. So we have quite a variety. I don't even know if I can name or number how many we have. But at the end of the day, what the skills do is they fetch data and they process it, and then Copilot kind of does the analysis. There's, some external calls or like API kind of calls, and then we're, formatting that to go into a prompt, which Copilot will, or I guess the LM will use to do the analysis. This is another lesson we learned for the data handling side of things. So we actually format our data into a JSON structure for consistency and clarity. We did a lot of experimentation around this. So, we started with things like maybe like a CSV, that didn't work so well. So we experimented and ultimately realized that Copilot did the best with data that was formatted as a JSON. So it's another major lesson learned. And I did go into that in the blog a little bit. And then I mentioned this before, but our skills do have the ability to directly interact with the user, and they can respond directly to them. They can also call, different tools or go back to the router there. So just wanted to kind of give a high level. I don't think there's too much in here that, you wouldn't expect from a tool. It looks kind of very similar to the skills that John showed you in the code-based experiment, code-based agent. And so that's kind of like how our skills work. And different routers might have access to different skills there. Okay, structured responses and streaming. Yeah, I just saw a question come in. Demo of Copilot. If we have time, I would absolutely love to pull it up and show y'all. We have some really cool skills in there. If not, there are some on our docs, on our website, on our YouTube, I believe, as well. Definitely check it out. I think my favorite are probably the AI search skill and maybe the prompt optimizer. Cool. So structured responses and streaming. This is another kind of tricky thing that we went through while developing Copilot. So we do use an EOM delimiter. So whenever you're streaming, there can be kind of difficulties of knowing when the LLM is done. So we actually, in our part of our prompting, we actually have the LLM split its response into it's just kind of raw text, and then using this EOM delimiter. So this allows us for easy UI integration and a really good customer or user experience, because it allows us to have confidence that the LLM is done responding, and then it just really allows us to kind of have that easy parsing in our UI and a just good user experience. We do combine this kind of streaming and structured output. So we have this strategy where we kind of aggregate responses until the LLM is completed. There is a little bit of a constraint here that we couldn't use streaming and structured responses in a single call here, and we needed both. That's why we kind of came up with this way of being able to kind of stream the text, but then use the EOM for other parts of it. So that's another lesson learned, and it's a challenge that we definitely face with what's the best user experience about getting Copilot's responses back. And with that kind of goes the handling of large outputs. So there are some skills with very verbose outputs. So you can think of maybe somebody gives a long prompt for us to optimize. That's going to be a long response back, or if they're wanting some really in-depth analysis of something, it could be a very long output. And there's sometimes some additional formatting we have to do about that. So we try to kind of have these additional tools and additional layers in there that helps us manage these really large outputs, and make sure we don't have any character overflow issues. And so yeah, that's a little bit about our structured responses and streaming. Something I didn't put in the slides, but that's worth mentioning, that's kind of related to the large outputs. We sometimes have tools that just format things. So there are these outputs that we get. Perhaps we have it in a very structured way, and then we have some tools to kind of maybe clean up the output. That does add just a little bit of latency, but we found that it's worth it to get the responses in a way that's going to be best for the user experience there. Cool. And I think that's just about it for the Copilot parts. Let's see if there's any questions there. Again, that's a high level. There's a lot that we could go into with Copilot lessons learned, but I think the main point I wanted to call out is some of the reasons we chose to build something from scratch. And so all of those things I mentioned were kind of highly specialized to our needs for Copilot, and there wasn't one really concrete frameworks available at the time, and nothing especially that met all of our needs. And so those were some of the reasons that we chose to go with this approach, and we have no plans to switch it. So Copilot is in production. It's released to all of our customers who want it. And so it's good to kind of have that real life example of an agent in the wild.
Awesome. Very cool. We have a couple questions. There's one which is about whether, I think you maybe touched on this, charting and table, whether we use a separate skill or LLM call to render charts and tables in the response, or if there is a structured data approach that we use instead.
Yeah. So we handle charts and tables in a few different ways. We're really going to be leveraging that EOM delimiter to do a lot of this. And so sometimes it is a separate skill, not Not necessarily an LLM skill or an LLM call. It's actually never one of those, but we have sometimes some processing that's done. And then we do a lot of that. We kind of take that data and maybe like have more like front end capabilities that take that and, you know, render it as a chart, render it or style it as a table in the actual Copilot interface. So I would say that it's more happening outside of the LM, outside of the Copilot skills, and just we're leveraging that structured response to render it.
So we got another one on any insights on how best to approach building Gen AI-based products, specifically around how to run, best ways to run project management projects.
Yeah, I think I don't want to pretend that I'm like an expert in this. I don't think anybody really is at this point in time. We're a little early on, but I think the approach on building a Gen AI based product, I think where I come from when I'm looking at Copilot is I'm trying to build things that I think my users really need and really benefit from, especially when I think about where to put Copilot and where to put it in our product. You know, something that I've been pretty passionate about is not putting Copilot where it didn't belong, not just sticking it somewhere just for the sake of sticking it, but trying to stick it somewhere that actually makes sense, is going to actually facilitate and make a user, or facilitate workflow and make a user's life better. So I always try to come from the customer pain, see how I can help them in their day-to-day in a way that's going to enhance our product. I also don't want to have two separate products. I want to have, you know, Arize that has Copilot that's a huge help to the Arize workflows. Product management, I think there's a lot of unknowns when it comes to the Gen AI applications. So I think stay involved, be flexible, and be able to adapt, because things sometimes go wrong. Skills don't work the way that they want. Skills are working, and then you switch a model out and now all the skills are broken. So I think just kind of having some flexibility built into it, and making sure that you have all your requirements and your ideal experience mapped out is something I would say.
Awesome. I do want to make sure, actually, Matthew, sorry, we haven't circled back. I promised we would do this. So
Yes.
question for Matthew on topic of LLMs behaving and not defining your output requirements and formatting. So anything you can share on how did you convince the LLM to kind of respond in the right way? Generally?
Yeah, so this is definitely something that's tricky. So I think there's a few levels of this. I think there's the function calling aspect. That's another thing I touch on in the blog, and I think you and I were talking about, John, is like sometimes you think the LLM it's going to be easy for it to call the right function, and then it's just not. So I think that's a struggle, and that actually kind of I found has to do with those descriptions you were showing and those tool definitions. So I definitely, some advice on that, if you're having trouble with that, is don't overlook that. Spend some time kind of engineering those descriptions. We found that to be a lot of helpful, and in our prompts a lot of the time, I give some kind of function calling guidelines. So saying like, call this function if this, and this is where this function might be helpful, things like that. And then output requirements and formatting. I think this one is tough. I still have examples where, you know, I'm working with Copilot and it spits out a response and I'm like, that's not what you're supposed to be doing. I think it's a lot of prompt engineering to try to get that kind of structured response. As I was explaining, we like in our prompts will say, you know, do this, and then after this EOM deliverer, I want you to respond in this way, and here's an example. And then we leverage kind of tools outside of that to try to force it as much as we can to get the output that we're expecting. So I think it's a little bit of prompt engineering, trying to be very specific and providing an example of what you need, and then relying on some kind of other tools to help make sure that you're getting the response that you're expecting. And I think it's imperfect. I still run into situations with this all the time where things are not looking the way they're supposed to. So hopefully that's helpful.
I'll throw in there one other thing too, is that Sally, correct me if this is wrong. I had a lot of trouble trying to get it not to do things. Like I wanted my router not to respond with SQL. And if I said anything in there, even like do not respond with SQL, because of the way that it works, it doesn't get the negation all the time.
Yeah.
So I had more success telling it what to do than what not to do, which is maybe just prompt engineering 101, but like I think that's worth mentioning.
I don't know if it's prompt engineering 101, but it's definitely prompt engineering like just I think helpful hint or guideline there. But yeah, there's definitely a lot out there that it's like it does better when it's told what to do, what not to do, because it sometimes will hang on to the wrong thing. Like you said, do not do SQL, and it's sort of okay, SQL, and it will hang on to that. So I definitely think that's really helpful. Describing as explicitly as you can what you want it to do, I think is really a really good point to make.
Yeah. definitely. Eventually, we might be able to follow up with some customer stories afterwards. I don't know if we have a great one for that, but I think we can maybe follow up there. There's one other question from Terry on the Q&A that I want to make sure to cover in the last minute we have here. Going back to some of the Crew AI and LangGraph, so the frameworks, what about, so Crew AI, for anyone who doesn't know, is built on top of LangGraph. And so there's a question around what we think of the approach of Crew AI built on top of LangGraph for the first agent app, and then layer in workflows, LlamaIndex workflows on top for scaling beyond a simple agent app approach. My reaction is probably don't want to use both those frameworks simultaneously. I think you're sort of using LlamaIndex and LangChain at the same time in that approach. And I think that I would say maybe start with, it's a little strange of an approach to me, but I feel like just using LangGraph and then doing your own kind of orchestration on top like Crew AI does could be more of an approach than trying to combine the two frameworks together in LangGraph and workflows. But yeah, Crew AI is definitely got an interesting approach for that. And it works very well for some use cases. So. Okay, we're 1 minute over. I know. Thank you everybody for all of the time and attention here. If you haven't tried out Arize or Phoenix, please give them a shot. Arize is our enterprise platform. You can sign up for a free account on the box on the left. Box on the right is Phoenix, which is our open source platform. If you're using Phoenix or if you're just feeling generous today, please follow that box and give us a star. Every star helps on the Phoenix side. That's how we know what we're doing on the open source side works. So thank you, everybody, and a bunch more content coming up for the next few weeks. And hopefully we'll see you for our next session on agents. Thank you very much. Take care and have a great day.